So I'm going to begin this question. We're going to solve for theta. We're looking for all angles theta between 0 and 360 within one revolution that have a tangent ratio of 1.7. Now, note that tangent is positive, so a good leading question is, where is tan theta? Positive. Well, tan theta is positive wherever the slope of our terminal arm is positive. So it is positive in quadrant 1 and quadrant 3. So that's where I know that I have my solutions. So what we see here, though, I'm just going to write tangent theta is equal to 1.7. I wish to solve for theta. What must I do to that equation? Really, I must apply the inverse tangent ratio to both sides. And allow me to do that, so I'm going to apply the inverse tangent ratio to this side, the inverse tangent ratio to this side, and what I end up having is that theta is equal to 59.534 degrees. And I know that my solutions lie in theta 1 and theta 3. So what's going on is that this is my theta 1 solution, my first quadrant solution. Now, what is my theta 3 solution? Well, how far is 59.534 away from the x-axis? Well, it is the same distance. So my theta 3 solution is going to be 180 degrees plus 59.53 degrees. So after figuring all that out, so I can get my solutions, theta is equal to, now I'm going to put it in set brackets, 59.534 degrees and 239.534 degrees as well. All right, there we are. Just make sure we know what we're doing. That question's over. But allow me to ask you this. What is the tangent of 59.534 degrees? What is the tangent ratio? Well, the tangent ratio, well, let me figure this out. Oh, it's 1.7. Exactly what we were looking for, right? Anyways, no, this is just notes and really just reading. If theta terminates in quadrant 1, our reference angle is theta. Like if you're ever trying to figure out how you can find yourself or how you can find the distance away from the x-axis, here's what you could do. So if your theta terminates in quadrant 1, by definition, your reference angle will be your angle. If theta terminates in quadrant 2, well then my reference angle is just going to be 180 minus theta, the distance away from the x-axis. And if you use your spatial reasoning a little bit, you'll come to the same conclusions. If theta terminates in quadrant 3, we have your reference angle is 180. This is wrong. Should be theta minus 180. And if theta terminates in quadrant 4, your reference angle will be 360 minus the theta that you're given. All right, hope this helps. Let's carry forward.